All right, the purpose of this video is going to be to size our disconnect for our motor circuit. If you've been following along, we've already done our motor conductors, which we found in part 2. We did our overload protection. In part 2 was 430.22 is where we spent most of our time, multiplied by 125%. Our overloads we found in part 3, which is .32, is where we spent most of it. And then in part 4, we did our overcurrent protection device. Now we're going to size our disconnect. I will say, no bullshit, sizing a disconnect is the hardest of the calculations that we're going to do because there's a lot more moving parts than there was in the previous 3. Okay, so using codology, we're going to find disconnects in Article 430, and we're going to see that that is in Part 9. This is based on Electrical Training Alliance Motors Level 2, Lesson 9. And I am going to, if you're following along at home, we're going to be doing questions 1, 6, 7, 15, and 16. So, when we see Part 9, it says that we want to go to page 314. I'm going to cheat a little bit because I know that we're specifically going to 430.110. And in 430.110, I will shrink it up here a little bit. Here's 430.110 over here. And we are going to roll right into it. So we have two different ratings that we could have to solve for. We could have an ampacity rating. Disconnects are rated in ampacity ratings, or disconnects are rated in horsepower ratings. Okay, so we have to be prepared for both. In this case here it is 430.110A, kind of lays out pretty solid for us right at the very beginning. The disconnecting means for motor circuits rated 1,000 volts or less shall have an ampacity rating not less than 115% of the full load current of the motor. Nameplate we can only use for overload. So now that we're back on disconnects, we have to go back to our table amps of 430.248 for single phase or 250 for 3-phase. Curveball number 1, that doesn't apply when we're talking about locked rotor current letter ratings. And we are going to do those, I pinky promise. And in fact, they're coming up. I think it's the second question we're going to do. But in this case here, we'll soft pitch it. We've got what is the minimum current rating for the motor disconnecting means for a 40 horse 208 volt 3-phase squirrel cage motor. We already know that we're going to multiply whatever table amps we get by 115%. So when we have our ampacity ratings, I want us to keep that 115, at least for this video, we're going to keep that 115% locked into memory. So I'm not going to keep coming back to 430.110. All right. But when we get into our horsepower rating, we are going to see that we're going to have, if we have our locked rotor current values, we're going to use table 430.251A and B. A is for single phase, B is for 3-phase, and we're going to discuss those. I know for sure we're going to discuss them on at least one of the questions that we're doing here. Okay, but that is for locked rotor current values. So again, going back to our question, we know that we're going to multiply by 115%. So we will bring up our calculator. We'll start off with 115%, and we're going to multiply that by the table amps that we find. And this is a 3-phase motor, so that's going to be 430.250. And when we go there, we're going to find a 40 horse 208 volt. So 40 horse 208 volt. I'm going to multiply that 115% by 114 amps. Hopefully we can all find that 114 amps. And we're going to see that my ampacity rating, my current rating for my disconnect is going to be 131.1 amps. So for my ampacity rating, that's really it. Not a whole lot to it. So moving on into maximum locked rotor current. This is where it gets a little dicier. All right. So when it asks me for my maximum locked rotor current, one of the spots we really haven't talked about is it's at the very, very beginning of Article 430, and it's Table 430.7b. 430.7b, if you turn to 430.7b, and again, keep in mind you can pause and then push play when you're ready. But I'm going to go right to 430.7b here, and you can see that I've got this fancy table. All right, so on my fancy table, I see that I've got 430.7b locked rotor current indicating code letters. So you can see over here, I'm given a code letter of D for my locked rotor current value for a 15 horse, 208 volt, three-phase motor. So, no lie, we're going to pretty much just use, we're going to use Ohm's law. So my power is going to be 15 horsepower, and I got to multiply that by, over here you can see on my 430.7, table 430.7b, my code letter D has a maximum value, or it has the values of 4.0 to 4.49. I have to use the maximum value. No matter what calculation I use, when I'm looking for my minimum horsepower rating, I have to use my maximum locked rotor current value. So I'm going to use 4.49. Now that 4.49, if you look at the top of that column, says that that is my kilo volt amps per horsepower. So I can take that 4.49 and I got to move the decimal point over 3 places to the right. So that will give me 4,490 volt amps per horsepower. So I got to multiply that by the 15 horsepower motor that I have. Now, what is my voltage? Well, if you just said 208 volts, you're not wrong as far as it's a 208 volt motor, but the problem is it's a three-phase motor, and if we remember anything about three-phase when it comes to voltage, I got to multiply it by 1.73. So when I do that, all said and done, I'm going to take my 15. I lost my cursor, sorry guys. I'm going to take my 15, not on the calculator, 15 times 4490, and I'm going to divide that by, you can either put parentheses around it and do the 208 times 1.73. I'm just going to divide by both, so divided by 208 by 1.73. And that is going to give me my maximum locked rotor current of 187.17 amps. Okay, so again, it's just P divided by E. So now we're going to combine that maximum horsepower rating on that, or I'm sorry, that maximum locked rotor current value to find our minimum horsepower rating for our disconnect. Okay, so how we accomplish that, and we're going to do the math the exact same way we just did. So we're going to find the minimum horsepower, but again, by using the maximum locked rotor current for our 50 horse, 440 volt, three-phase marked with a code letter B. So my code letter B, if we look at that pretty closely here, we'll see that my code letter B has a maximum locked rotor current of 3.54, so 3,540 volt amps per horsepower. Have to multiply that by the 50 horsepower, and then I'm going to divide that by voltage in 1.73 because it's three-phase. So divided by 440, 1.73, I get a locked rotor current value of 232.52 amps. Now, because it's asking me for a minimum horsepower rating, I actually have to go through and find out what amount of horsepower, And I can't use 746 for this. I actually have to go to a table in the code book. And those two tables that we talked about before, tables 430.251a, 251a is for single phase, but this is not a single phase, this is a three phase. So I've got to go to 430.251b. And 430.251b is for my three-phase locked rotor horsepower current blah blah blahs. So let me make the table a little bit smaller because I can't quite squeeze everything in there. So now I'm looking for the 440 volt column, which you can see is all the way over here on the right hand side of my screen. And we're going to now scroll, we're going to go view down this way until we find a value that is bigger than 232 amps. And the value that is over 232 amps is right here, 290. And when we go all the way over to the left-hand side, we can see that that is a 40 horsepower switch. So my disconnecting means has to be a 40 horsepower. If I'm doing horsepower rated, I would have to get a 40 horsepower disconnect. Okay. Now it throws, here's my next curveball. It's going to be one 5 horsepower motor and one 10 horsepower motor, both continuous duty, 460 volt three phase installed on the same 480 volt motor circuit. They can be started simultaneously. Calculate the minimum ampacity of the switch. So, because I have to use my regular table amps, because again, now I'm looking for the minimum ampacity. I don't have to do anything with locked rotor current. I don't have to do anything with any of that. All I really have to do now is I have to go on to, I have a three-phase motor, and again, I can't use nameplate amps. I wasn't giving them anyway, but I can't use nameplate amps even if I was giving them. I've got to come up and find them on my three-phase table. So when I come up here on my three-phase table, 430.250, I find that I have got 5 horse 460. 5 horse 460 is 7.6 amps. And I need to add the 10 horsepower motor at 460, which is 14 amps. And when I do that, I get a total of 21.6 amps. But because I'm finding my minimum ampacity of my disconnect, if you remember from 430.110 at the beginning of the video, I've got to multiply that value by 115%. So that means I have a minimum ampacity of my disconnect at 24.84 amps. Everybody good? Let's hope. All right, so now I'm going to have the same two motors. One 5 horsepower motor and one 10 horsepower motor. Still same 460 volt three phase, installed same 40. It's the exact same thing. Only now they're saying I got to solve for the minimum horsepower rating of the switch. Because I don't have any locked rotor current values, that helps me quite a bit in this case, which I don't. So now I just have to go to my table of horsepower ratings, three phase, 430.251b. And now that I'm here at 430.251b, I go to my 460 volt column, and I'm going to go find my 5 horsepower, and that is good for 46 amps. And now I look at my 10 horsepower, and my 10 horsepower, if I look over on the right-hand side at the 460 volt column, I see I've got 81 amps. And again, keep in mind, this is just finding the horsepower rating. I add those two values together, and I get 127. The only time I multiply by 115% is if I'm looking for the minimum ampacity of the switch. In this case, I'm looking for a horsepower rating. I've taken my horsepower values, or my current on my horsepower values, I've added them together, and that's all I really have to do. Now what I have to do is find a value that's bigger than 127 amps in my 480 volt column. So I'm going to come down here, and the number I get that's over 127 is right here, 145, and that is a 20 horsepower switch. Okay, that is it. I wish everybody the best on the homework. If you have any questions, feel free to call me. Other than that, enjoy.